everyone, my name is Kylie, and today we're going to be talking about vaccines. So we're going to talk a little bit about how they work, where they came from, so a little bit about the history, and also why they're important. So let's jump right in. So let's start with what vaccines do. So you guys have probably all had many vaccines in the past. When you go to the doctor and they give you a shot, but you feel perfectly healthy, sometimes that's what they're giving you. You probably started getting vaccines when you were really little, like around 6 months old, so before you even remember. Basically, vaccines help your immune system become better at fighting certain infections, such as chickenpox, polio, the common flu, measles, mumps, and more. Vaccines give your body practice at fighting certain types of germs, or pathogens, so that the next time your body sees that pathogen, it will fight it better. If you play an instrument or if you've ever been in a school show before, just think of it like a dress rehearsal for the real show. There's no one in the audience, so the stakes are pretty low, and you need that practice to do your best performance later. A really important definition for this lesson is that a pathogen, or a germ, is a bacteria, virus, or microorganism such as a worm or a fungi that can cause disease. That's all it is. So why do vaccines work? In order to answer this question, we need to talk about something else first. So we're kind of surrounded by pathogens and germs, but you shouldn't be scared. We all have a system in our body that is in charge of preventing and fighting infections called the immune system. Your immune system is constantly keeping you healthy and safe in the face of germs that want to make you sick and feel horrible. And it does a pretty great job too. In this lesson, we're only going to talk about it a little bit, but there will be whole videos about this soon if you're interested. Your immune system is in charge of keeping you healthy. It does this with 2 different types of cells that circulate throughout your blood and keep watch for organisms or germs or pathogens that are out of place. Some of these white blood cells are called phagocytes. Phage in Latin means to eat, so these cells chew up invading pathogens. This is also called your innate or non-specific immune response. It acts very fast to start battling these pathogens, but it doesn't last that long and is not effective long term. It is called non-specific because it does the same thing whenever it encounters any pathogen. Other cells, called lymphocytes, have memory for things that your immune system has seen before, so that when you see them again, you can fight them better and faster. This is called your adaptive or specific immune response. This branch is able to target specific pathogens and fight them quickly and effectively. So, what is a vaccine exactly? Vaccines play with the idea that your body's immune system has a memory for what it has seen in the past, those lymphocytes we were talking about. A vaccine is a weakened version of the pathogen that normally causes the disease. So instead of the full bodybuilder coming to fight, it's him after not eating for several days and not sleeping for 3 weeks. So it's easier for your body to fight him. Sometimes it's a dead bacteria or an inactivated virus. This weakened version is not strong enough to hurt you, and it is completely safe. This weakened version helps your immune system develop the right antibodies to recognize that pathogen in the future. Antibodies are proteins shaped like a capital Y that recognize and latch onto specific pathogens in your body to call other cells to come and eat the germ, and they can act really fast. In the picture, you can see that antibodies, the blue Y-shaped thing, has a binding site that attaches to specific sites or antigens on pathogens. Antibodies are only made once you have seen that pathogen, so this is why vaccines are important. If your first time encountering a really bad disease is when the germ is very deadly and at its full strength, or is that big bodybuilder after a full day of eating and training, you are going to get very sick. But vaccines make it so that if the full strength germ comes at you later, you've already gotten the antibodies to fight it. So what are some of the diseases we have vaccinations for? There are dozens. Some are better than others at making you immune or safe from certain infections. This is a list of just a few of them. You have polio, measles, mumps, chickenpox, the flu, tuberculosis, and more. You will likely not have had all of these vaccines. This is because different countries in different parts of the world have different diseases. So the vaccines you get depend on where you live and how likely you are to see that particular bug. For example, we don't see a lot of yellow fever in the United States. so we don't normally vaccinate for it. And if you travel to certain countries, you might need to get some new vaccinations. So let's talk about the history of vaccines. I think that the history of vaccines is super cool because it's a lot of trial and error and observation without knowing and lots of happy accidents. So the concept behind vaccination is not new at all. People in different cultures noticed nearly 1,000 years ago that exposure to a certain pathogen made it so you would become immune to it later. The story says that the Emperor of China in the 10th century lost his son to a disease called smallpox and wanted to protect the rest of his family. So he called upon medical healers, magicians, and doctors throughout his country to bring forth ideas about how to protect his family. A divine man from Mount Ime is said to have come up with the idea of inoculation, which is just another fancy word for vaccination. But it's really hard to say when these practices actually started. Either way, this practice of inoculation was to grind up the scabs from people infected with a mild form of smallpox and then put them into the noses of healthy children. Now, I understand that this is gross, but it worked. The children got a little sick and then they became immune to smallpox for the rest of their lives. This practice was used in Eastern countries such as Turkey and China for hundreds of years, but Western countries like England, France, Italy, and Germany were resistant to trying it. So enter Edward Jenner and the story of smallpox. This is our first real vaccine, and it's very much credited with being the first and the start of a whole new era. So smallpox, as mentioned in the last story, was a nasty disease that killed a lot of people before vaccines. This disease is caused by a virus, and it is spread through respiratory droplets, so like sneezing or coughing into somebody's face. When you get smallpox, it causes a whole body red rash, flu-like symptoms, so you get a fever, you feel really tired, you get a headache, and blisters. It usually lasts about 3 weeks, and it's very dangerous. So nasty and dangerous that it probably killed between 300 and 500 million people in the 1900s. But I don't want you guys to worry at all. The story of smallpox gets a very happy ending, but we aren't there yet. A man named Edward Jenner from England noticed that milkmaids never seemed to get smallpox. They were immune for some reason. These people worked with cows in the barn all the time. Jenner theorized or thought that because they had been exposed to cowpox, a virus very similar to smallpox, they became immune to smallpox. So he tested his theory and exposed a young child to cowpox. He then exposed that child to smallpox, and the child was immune. Just for the record, this is not how vaccines are tested and developed nowadays. We don't expose children to potentially deadly diseases on purpose, and we go through a lot of other steps before we even think about testing our vaccines on humans. He was the first person to conduct clinical trials and be recognized by medical professionals. So this is actually where the word vaccine comes from. Vaca means cow. So now whenever you think of vaccines, I want you to remember that we owe it all to cows and cowpox. Also, fun fact, smallpox and cowpox are not related at all to chickenpox. Bring that fun fact out for your friends and then tell them to Google it when they don't believe you. So I want to quickly introduce germ theory. Germ theory just says that pathogens, or germs, which are too small to see with our own eyes, cause infectious disease. That makes sense, right? Before germ theory, people had all kinds of beliefs about what caused disease. The most popular one in Western culture, so Italy, England, France, Germany, was that bad air, or miasma, caused disease. But a French man named Louis Pasteur changed that and really gave a lot of evidence to support germ theory. Another thing Louis Pasteur did was produce a ton of vaccines. So here's a fun story that I absolutely love. One week in 1880, so only about 150 years ago, he went out of town and left his research about avian cholera, a disease that only infects birds, in the hands of his research assistant. The research assistant forgot about the experiments and did not infect the chickens with the bacteria he was told to. When the assistant realized his mistake, he took the mixture that had been sitting out for days and days with the bacteria and injected it into the chickens. and normally this would kill the chickens and make them very sick. I'm sorry, that's kind of a bummer, but this time the chickens did not die. He tried again with a new mixture that had fresh avian cholera bacteria, and again the chickens were fine. He had no idea what was going on. But when Pasteur heard about this event, he had his assistant repeat the experiment with some new chickens. And again it worked. Pasteur realized that the stale broth mixture with avian cholera bacteria helped protect the chickens from active infection with the more deadly and alive disease. He realized that a dead or weakened version of the germ or pathogen could induce an immune response and help make the person or chicken immune. He used this discovery to produce many more vaccines throughout his life. Just a note, a lot of the greatest discoveries in science happen when you're looking for something else or when you make a mistake. So always be open to making mistakes. Just make sure you look for answers after and ask a lot of questions. So Louis Pasteur's discoveries and methods essentially went viral. Many vaccines were developed in the years following Pasteur's accidental discovery. This method was to isolate the germ, so the bacteria, virus, or microorganism, and weaken it somehow. Leave it out for a few days, heat kill it, expose it to a certain chemical, whatever worked. Then you had to try it out on some animals. So give them the weaker version of the pathogen and then expose them to the real pathogen a few weeks later. If this worked, you could move on to test trials in humans to see if it worked for them too. Many vaccines have been developed since Louis Pasteur's happy accident and discoveries. But the path of vaccines has definitely hit its fair share of bumps. Sometimes the vaccines didn't work like they were supposed to, or they were contaminated with another germ, like tetanus or a different disease. However, each incident caused more rules to be put in place to protect people and make sure that vaccines were safe and effective. And a lot of this happened between Louis Pasteur's discoveries in 1880 until 1930s or so. So our next character is John Enders, also known as the father of modern vaccines. Enders was an American scientist in the mid-1900s who helped develop the measles vaccine. He's kind of a prime example that people can be good at many things and change careers later in their lives. He got his master's degree, so a whole level above college, in Middle English, which was the study of the language people in England used from 1150 to 1470, so a really long time ago. And towards the end of his schooling, he changed his mind and applied to PhD programs in microbiology, the study of super small living organisms. And I don't think there are two more opposite fields of study, except for maybe chemistry and theater. He changed his mind essentially because he thought his roommate's homework was cooler than his homework. Later on, he researched how to grow viruses, specifically poliovirus, which had been a very tough nut to crack. While other vaccines were popping up everywhere, viruses were harder than bacteria to isolate. Remember step 1 of making vaccines? Isolate and grow it? John Enders made that first step possible for poliovirus. So the vaccine for polio was created shortly after John Enders was able to isolate and grow the virus. So polio is a viral disease that can cause paralysis in the early 1900s, it caused a lot of children to become disabled and paralyzed. Another fun fact is that our 32nd US president, Franklin Delano Roosevelt, was paralyzed and used a wheelchair, and this is likely due to a polio infection he had when he was 39 years old. In 1952, a man named Joseph Salk created a version of the polio vaccine, and 9 years later, in 1961, Albert Sabin created a polio vaccine. They had different ways of working. Salk's vaccine was a killed, or dead virus that was given in a shot. Sabin's was a pill that used a live virus. Their rivalry was one of the greatest of the 1900s science scene. They hated each other and constantly said bad things about one another and tried to discredit their work. Sabin would say that Salk's vaccine was dangerous and that Salk was stupid. and Salk would say that Saban was a con man. You know, the typical rivalry. We've gone back and forth as a field on which vaccine is better, but nowadays we use Salks, so we get shots to make sure we don't get polio. And the great part about this story is that we don't see a lot of polio in the United States anymore. These vaccines worked super well. In fact, in 1979, it was eradicated in the United States. Eradicated just means that it's gone. We never really see cases of polio in this country anymore. And most countries are like this. But 3 countries still see some cases, and these countries are Pakistan, Afghanistan, and Nigeria. So let's go back to smallpox. I told you the story of smallpox had a happy ending. In 1959, over 150 years after Edward Jenner's discovery, the World Health Organization began a campaign to eradicate smallpox worldwide. By that time, smallpox was already eradicated or gone in North America and Europe. Through a lot of hard work, the World Health Organization managed to vaccinate every single person who needed it in South America, Asia, and Africa. It was eradicated in South America in 1971, and Asia in 1975, and finally in Africa in 1977. The last person to ever get smallpox was a young girl named Rahima Banu in Bangladesh. She was kept in isolation until she couldn't infect anyone else, but she lived and the world was declared smallpox-free. So let's just talk a little bit about why vaccines are important. Let's start with some numbers. Vaccines are estimated to have saved at least 10 million lives between 2010 and 2015. The work of John Enders, our Middle English friend, is estimated to have saved 120 million lives since 1948. Another scientist who we did not talk about, named Maurice Hilleman, created over 40 vaccines in his life, and these vaccines save about 8 million lives per year. So vaccines work in 2 big ways. Vaccines help you stay healthy and safe from certain infections, and that's a huge deal. The other thing it does is protect the people around you. In order for a disease to spread throughout a group of people or a population, it must be able to infect some of them. If most of the group is immune to that disease, because they are vaccinated or they're immune for some other reason, the disease will spread less quickly and infect fewer people. This is called herd immunity. So if you liked this topic, here are some additional activities that you can do to learn more about how vaccines work. The first one is an online game at vaxpackhero.com where you can team up with a vaccine to help defeat invading pathogens. The other is a coloring activity with fun little games in the packet. If the link does not work, you can Google Vaccines Activity Book, Vaccine Education Center at Children's Hospital of Philadelphia. So I hope you enjoyed this video. I had a lot of fun researching it and making it. I really do think that vaccines are kind of the greatest things ever. I think that they are so important to understand and use because they help us fight a lot of diseases that could really hurt us if we aren't vaccinated. And they've saved more lives than almost any other modern invention or technology, except for maybe flushing toilets and clean water systems. So that last slide was just a list of my links for pictures and some of the information I used. So I hope you guys really enjoyed hearing about how vaccines work and why, and I hope you guys can tell all your friends about why they're important and you feel confident in your ability to tell your family how they work. So I hope you guys have an awesome day. It was awesome getting to see you guys, and thank you for watching. Bye!